Okay, so I kind of want to go over today, going over the vertex of a parabola. So there is a student that I have who's actually going over this currently. So this kind of made me want to go over this topic. So this is a topic in algebra. Typically, I think algebra 1, algebra 2, something like that. And really, what it is you're finding a specific point on a graph. It's a very specific point. So if you kind of notice here, I have this generic function f of x, sometimes we call it y, is equal to ax squared plus bx plus c, where you can tell by the color coding that a, b, and c happen to be coefficients. They're typically constants in an algebra case. And if you kind of look over here at this graph that I have over here, this XY graph, I have my x-axis going to the right, my y-axis going up, and then I have this kind of a hump shape, almost like a hill shape. That's what's called a parabola. And so parabolas can either go upside down like this one is, or it can go up so it looks kind of like a U. I'm going to do the upside down one just because I think it's kind of harder for, I think, most students or for just most people to kind of get. So really what we're asking for, what is the vertex of a parabola? What's a vertex of that graph? And really what a vertex of parabola is, where's a point where the slope is equal to 0? Where's the point where you go from positive, you start going from positive, start going to negative? Where is that point that is basically 0, where the slope is 0? And that would be this guy right here, right? And so the question is, well, how exactly do you find that point, right? And so it's like, well, let's go and figure it out. So if you see down here on my example, I have an example of y equals minus 5x squared plus 25x minus 2. So this is a quadratic formula, right? We have polynomials of different orders. And there's two ways we can go about this for solving the vertex of a parabola. There's the algebra way of going over this, or there's like the calculus way of going over this. And I'm going to go over both and explain why I like the calculus one, I think, better. So as far as algebra, if you're an algebra student, don't worry about the calculus one, honestly. You'll never need to know it. And simply, if you're an algebra student, there's a certain formula, which is that the X vertex is equal to negative b over 2a, right? And really what the X vertex is that's the X point, right? So here, as we set up here, f of x equals ax squared plus bx plus c. So this b in this case would be tacked on to the x. So in this case, it would be our x vertex, just called our x, equal to negative b. Well, b happens to be 25, right? Over 2a. Well, what's a in this case? It's a negative 5. So b minus 10, right, equals, you can reduce that a little bit. It's going to give you positive. It's going to be 5 halves, positive 5 halves. So now that you have your x vertex, your x point, right, you know where it is exactly on this graph. We need to know the y part. And simply, you take this value and you just plug it back into this guy to figure it out, right? So we have y is equal to minus 5 over 5 halves squared plus 25 multiplied by 5 halves minus 2. It's going to give you y equals minus, well, it's going to be a minus 5 times 25 minus 125 over 2 plus 25 times 5. It's also going to be 125 over 2 minus 2 minus negative 125 over 2 plus 125 over 2. This whole thing goes to 0. Y equals minus 2. Right? So our vertex pair, so our answer, our vertex pair, is going to be 5 halves, comma, minus 2. So if you kind of see up here on the graph, I kind of drew this randomly. I actually didn't know exactly where the vertex is. I just drew a random parabola that I know is going, it was sloping downwards because of the negative sign here at the negative 5x squared. So this actually should be lower, honestly. It should be more like down here or around there. Anyways, So kind of going forward from that, that's really just the algebra thing. If you can remember this formula, then you're pretty much good. Remember, that gives you the X vertex, plug it back in to get the Y, you're set, right? So let's go into the calculus way. Remember, I think it was something like Y is equal to negative 5x squared plus 25x. I think it was plus 2, if I remember right. Minus 2. Just for the check. Minus 2. Okay. So if you're like a calculus person, kind of like me, when I said something about the slope being equal to 0, should have really rung your ears. And really what that means if you're a calculus student is you're going to take a derivative. And you're going to set equal to 0 because the derivative is the rate of change of, your slope. So that being said, what we're going to do is we're going to take the derivative of this function with respect to x. So we're going to take dy dx equals, it's going to be negative 10x plus 25, and we're going to set this derivative equal to 0. Why? Because it's the slope. All right, cool. So solving for both sides, we have negative 10x plus 25 equals 0. We have negative 10x equals negative 25. X equals 25 over 10. Reducing that gives us x equals 5 divided by 2, which happens to be the x vertex that we got beforehand. And in order to find the y vertex, you do the exact same thing. Remember, what was that again? It was just negative 2. So we're going to get the exact same vertex again. So this is like the calculus way of doing it. Calculus way. And this is let's make this in, this is the algebra. That's the algebra way. Cool. That's how you find the vertex of a problem.